Hello. One way to look at this problem is to first write the chemical equation where they are telling you that hydrobromic acid reacts with strontium hydroxide. Hydrobromic acid is your acid, so this is your acid. And the strontium hydroxide is your base. A neutralization reaction always produces a salt and water, so water is a byproduct, plus strontium bromide. The next thing you need to do is balance the chemical equation. As you can see here, you have two bromides on the right-hand side and only one on the left, so you must add a 2 in front of it. And therefore, to balance out the hydrogens and the oxygens on the left and right side, you need to add a 2 in front of the water. Another thing you could do is maybe write the amount of each solution given here to make the calculations easier. So if you have 25.0 milliliters of HBr, you're trying to find the concentration. So let's call it question mark M, which are the units for concentration in this case, molarity, which equals moles per liter. And then you also have here 17.7 milliliters of the 0.105 molar solution of the base. Molarity, remember that it's moles per liter, so all those milliliters have to be converted to liters. And we first must find the moles of strontium hydroxide to have the stoichiometric relationship between the base and the acid. So let me go ahead and write down what it's going to look like by using dimension analysis. So 17.7 milliliters. I need to go ahead and convert those to liters. So 1 liter has 1,000 milliliters. I can continue on by writing the concentration of strontium hydroxide to find the moles. And we know that 0.105 moles of that solution are present in 1 liter. At this point, we have moles of strontium hydroxide, so we can go ahead and do the stoichiometric relationship between the base and the acid. And we look at the balanced chemical equation where we have a 1 in front of the base and a 2 in front of the acid. So we have 1 mole of strontium hydroxide is going to react with 2 moles of the acid. So 2 moles of HBr or hydrobromic acid. At this point, we can go ahead and find the moles of hydrobromic acid. When you place in the calculator, remember that what's on the top multiplies, what's at the bottom divides, and I get on my end 0.003717. But this is not our final answer because this needs to be now converted to the concentration, which is molarity. So what we have to do next is divide this amount of moles over the 25 milliliters that have to be converted to liters. So I need to go ahead and say 25.0 milliliters. 1 liter has 1,000 milliliters. So you can see those units cancel, and your units are going to be moles per liter, which is the same thing as molarity. Let's pay attention to significant figures. It seems that the least amount of significant figures is here 3. So the final answer should be, according to what the calculator gives me, is 0.14868. But this is not to 3 significant figures, so we must fix it to 0.149 molar. And that's the concentration of the hydrobromic acid that was neutralized with that amount of base. Hope this helps.